Hey, welcome to Sciencefully. I am Siddharth Nair and here I explain scientific concepts intuitively. So get ready as we step into the world of science. Isn't it frustrating when you trip over something and fall down? But ever stop to wonder why you fell down? And no, it's not just gravity. There is something called inertia, and that is exactly what we will learn about in this video. Oh, and don't worry if you find physics a bit complicated. I'll try my best to keep everything as intuitive as I possibly can. Now, before I start with the actual definition of inertia, I want to give you an intuitive idea of what it exactly is. Imagine running really fast. Now try to halt completely as quickly as you can. Still with me? Great. Did you feel something preventing you from stopping? Did it take some time before you came to a complete stop? That is inertia. Alright, now the definition. So inertia is just the ability of an object to resist a change in its state of motion. State of motion depends on two factors, speed and the direction of the speed. So a change in the state of motion can be due to either a change in the speed or due to a change in the direction of the speed. And the definition of inertia can be rephrased as an object in the state of no motion will remain in that state, and an object that is moving will continue to move with constant speed along a straight line path unless an external unbalanced force acts on it. And that is Newton's first law simplified. And since the first law bears such a close relation to inertia, it is also referred to as the law of inertia. Now, I have tried substituting words out that might leave any ambiguity with the meaning of the law. So in a way, I have tried oversimplifying it. Now, if you are a physics enthusiast, let me make a couple of things clear. Firstly, inertia is by no means a force. It should not and must not be misunderstood as a force. Instead, it's something called a pseudo-force. A pseudo or fictitious force is a deceptive force that appears to act on an object because the point of view of the observer is accelerating. Inertia is just an attribute of every object to resist a force. Secondly, the object changes its state of motion only if the external force is unbalanced and there is a total net force on the system. And the net force on an object is just the total force on that object. And the force is unbalanced if the net force is not equal to zero. Let's try understanding this better with a little thought experiment. For example, a car in a parking lot is acted upon by the gravitational force of the earth. But Newton's law says that it should change its state of motion if there is a force. But the car seems to disagree. Did we just prove Newton wrong? Well, not quite. This is because the ground applies a force in the opposite direction of gravity to keep the car up. This is called normal force. This force exactly cancels out the gravitational force and hence the total force on the system is zero. The law holds. Now imagine that another car enters the parking lot and collides with the first car. Careless driver. Now let's look at the situation. The normal force still cancels out the gravitational force. No change there. But the collision means that there is another force on the car. So the car moves or changes its state of motion because the force applied is unbalanced. So understanding the first law requires a clear understanding of unbalanced forces. Now if there was someone inside the car, he may get hurt because his body would resist the change in motion due to inertia and he would slam into something in the car's interior. I am aware that I have referenced the word force a few times now. We will deal with force in extreme detail when we talk about Newton's second law. And since force is such a broad topic, I don't want to be diving deeper than is necessary for today. Inertia is abundant in our lives. Every object, be it big or small, faces it. It's better to take a run up before a long jump because inertia will help you farther than you would be able to jump from rest. Now, if every object faces inertia, is it the same for all? Well, the simple answer is no, it isn't. Inertia heavily depends on mass, no pun implied. If the mass increases, the inertia does too. If the mass decreases, the inertia also goes down. So a heavier object will have greater inertia than a lighter one. That is partly why it is harder to stop bigger vehicles such as a truck than it is to stop a car. Another thing I wanted to make very clear is that inertia does not depend on speed, as is commonly misjudged. The inertia of an object solely depends on its mass, that is, inertial mass. For now, we can assume it to be the same as mass, which is the amount of substance in an object. The reason it is often confused is due to the fact that an object's inertial mass increases with speed, and so does its inertia. So inertia increases only because the mass increases. This only brings substantial changes to the inertia in special cases when the velocity approaches the speed of light. For speeds considerably slower than light, this is not a problem. There is no method, according to our current knowledge of physics, to change the inertia of an object without changing its mass. Now, with all this knowledge, let's have a look at how inertia acts when you trip over something. When you're walking, your body has a certain motion, and inertia will resist change in this motion. So when you trip over, a resistant force acts on your legs, and they cannot continue with their former state of motion. But your upper body has not met such a force. Hence, it continues its motion forwards. As a result, your legs lag behind and you fall down. If there had been no inertia, you would just halt and stand still. Isn't it frustrating when you trip over something and fall down? Well, now you know why. But really, the best way to avoid it is be a little more careful next time. That is all for Newton's first law. Next up would be basic kinematic terms and concepts, and I shall see you there.